Hello students. So today I am going to discuss about work, heat, sign convention and reversible and irreversible process. These terms are very important to solve the problems in IIT JEE or NEET. These terms are very important to solve the problems in IIT JEE and NEET. Right? First coming to the work. What is the work? To achieve motion against opposing force. Right? To achieve motion against opposing force. The motion will be opposed by some force. The motion will be opposed by some force. Here work is to achieve motion against the opposing force. That is the work. Right. So we have two kind of work here. Pressure volume work, non-pressure volume work. We have two kind of work. Pressure volume work, non-pressure volume work. What is pressure volume work? So in thermodynamics we are going to study all the systems by using the pressure volume work only. That means in thermodynamics we are going to take one piston, right? When we are going to take one vessel with piston, inside this container gas will be there, right? Inside this container or inside this vessel gas will be there. This will be closed, right? And a piston will be operated. So this is called pressure volume work. This is called pressure volume work. In thermodynamics we are going to study the pressure volume work. The pressure volume work is designed with piston and a vessel where inside the gas. Inside there is gas, right? So non-pressure volume means W equal to work equal to force into Fs, right? Force into distance. That is the non-PV work. Here this is the PV work. I need you students to understand what is the first pressure volume work and non-PV work. PV work is involved in the piston vessel. Inside is the gas, right? So based upon the gas, expansion or compression happens. Expansion of the gas or compression of the gas. If you press the piston, compression of the gas. If piston will be pushed up, expansion of the gas. Compression of the gas, expansion of the gas with the piston. That is pressure volume work. Non-PV work means W equal to force into distance. So if object is moved some distance by force, right? That is non-PV work, right? Non-PV work. And coming to here. Now understood what is the PV work or non-PV work. Now PV work is two kinds, expansion and compression. PV work is of two kinds, expansion and compression. Suppose first system is like this. Suppose the system is like this, right? So here if you observe, it is compressed. That means piston is coming down, right? So inside what is there? Inside P gas is there. Inside P gas is there, outside some external pressure is there. Same here also. So if P external is more, opposite side pressure is more, it will push down the piston, right? Opposite pressure is more, so surroundings the pressure is more in the surroundings, it automatically push down the piston, isn't it? So if piston push down, so what will happen? The compression will happen. The compression of the gas will happen, so that we used to say P external is greater than P gas, right? If P external is greater than P gas, then compression of the gas happens. So one thing is important in examiner, if he mentions in question P external is more than the P gas, then compression will happen. So here what will happen? Here also P external is there, P gas is there. If P gas pressure is more, if P gas inside the pressure over here is more, it automatically the piston will be moved up, isn't it? Inside the pressure of the gas is more, automatically the piston will be moved up. So then we say here P gas is more than P external. P gas is more than P external, then expansion happens. So from this part, I request you student to remember three things. What is work? To achieve motion against opposing force. That is the first point you remember. The second point is work is two kinds, pressure volume work and non-pressure volume work, right? So in pressure volume work, thermodynamics we deal with the pressure volume work. In pressure volume work also we have two types, expansion and compression, right? So inside it is a P gas, this is the ideal gas. Inside this is the P gas, ideal gas. We can apply ideal gas equation for this. While doing calculations, while doing problems for inside the gas, P gas, we can apply ideal gas equation. What is the ideal gas equation? PV equal to nRT, right? So PV equal to nRT. We can apply this PV equal to nRT ideal gas equation for the gas over here. Okay, so so for compression, P gas is more than P external, right? So for expansion, P gas is more than P external, the expansion happens. If P external less than P gas, right? P external more than P gas, then compression happens. Right? So PV work involves compression and expansion. If in expansion P gas is more than P internal, in compression, right, in P external is more than P gas. So remember this condition. For P gas, we can apply the ideal gas equation, that is PV equal to nRT. Okay. Next, coming to the signing convention. While doing the problems, the signing convention also important. Right? He doesn't give the sign. We need to take up the sign from the question. We need to derive the sign from the question. If you take here heat, in some cases system absorbs heat. In some cases system absorbs heat. In some cases system releases heat. What is system? Yesterday I had told you. Anything the particular part under the study is called the system. Yesterday I have told you. If that system, that's why yesterday I have told you. What is the system, what is the surroundings, and what is the inverse. Okay, so yesterday means the part 1. You can go back to the part 1 and you can observe. If you don't observe that part 1 part. Okay, so system absorbs heat means it gains energy. Anything is there, it absorbs heat, right? It absorbs heat. If a compound is there, I hated that compound, that means it absorbs heat and it gains energy. It gaining energy always will give positive sign. Gaining energy, we will give positive sign. By absorbing the energy, by absorbing the heat, system is gaining energy. So for absorption, when it absorbs the heat, the positive sign will come. Right? Q equal to positive. Right? When a system absorbs the heat, there is rise in energy. So the signing conversion for Q equal to positive will come. When a system loses heat, right? When a system loses heat, there is decrease in energy. So decrease in energy means negative will come. So for Q, negative will come. One thing you observe. Always, otherwise you may confuse. One thing you remember, otherwise you may confuse. The thing is, if a system gains energy, or if a system there is increase in energy, then give the positive sign. For either it is heat or work. If a system loses energy, or decrease in energy, then give the negative sign. Here, heat system absorbing heat, it is gaining energy, that's why you have given positive charge. Here, system loses heat, it is losing energy, decreasing energy, that's why Q is negative sign. So coming to the work, heat we have given the convention. These are path functions, heat and work are path functions. For work, there are work done by the system, work done on the system. Work done by the system means, observe, work done by the system means, by doing the work done by the system means system is using its internal energy to do some work. I repeat, work done by the system means system using its energy to do the work. Work done by the system using some energy to do the work. There is decrease in energy of the system. So there is decrease in energy of the system. So work done by the system means negative charge will come. Work is negative, not charge. So work is negative. So that means expansion, right? Suppose this is a piston is there. Work done by the gas means what? Work done by the gas means it will move the piston up. That is the only chance, right? Work done by the gas means inside the gas is there. Work done by the gas means it will move the piston up, right? By moving the piston up, it is using its own energy to move the piston up. That means it is losing its energy. So losing energy means, so work done by the system is negative. Work done on the system, right? Work done on the system. So if P external is more, it is doing work on the system. System is gaining energy. So system is gaining energy means it is positive. If work done on the system, it is positive, right? So from these two cases, remember three things. What is work? To achieve motion against opposing force. It is a PV work or non-PV work. In thermodynamics, we deal with PV work. In PV work is just two types, expansion and compression, right? Expansion, if P inside the gas is more than the external pressure means expansion happens. If P external is more than the inside of the pressure, so then compression happens. Then coming to the signing convention, if a system gains energy means positive will come. If a system lose energy means negative will come. by gaining the heat, by passing the heat, there is increase in the internal energy of the system, right? By passing the heat, there is increase in the internal energy of the system. That's why when system absorbs heat or Q absorb, you will give the positive charge. When system loses heat, there is decrease in energy of the system. That's why if Q releases, right, our system loses heat, we will give negative charge. When coming to the work done by the system, means system is doing work, system is using its energy to do the work, thereby there is a decrease in the energy of the system. So work done by the system will get negative charge. Work done on the system means, so we are doing work on the system, that means we are pushing the piston down, or P external pressure is pushing the piston down. Work done on the system means it gains some energy, that's why work done on the system is positive. Reversible process and irreversible process. So reversible process and irreversible process, I will take this example piston with gas to explain that, right? So the reversible process is, right, so you have piston, right? So we have piston with gas, right? Piston vessel with filled with gas. So reversible process means, right? So suppose, right, the piston is moving from here to here. The piston is moving from here to here. Observe carefully. The piston is moving from here to here, from this place to this dotted line space. The piston is moved from this space to, and assume that expansion is happening. Whether it may be a compression or expansion. So here I have taken the expansion to understand you better, right? So suppose assume that in a piston expansion is happening, so the piston is moving from this line to dotted line, right? So in the same case also, another thing also, the piston movement is happening from this line to, from straight line to dotted line. In reversible process, it happens in 1,000 number of steps. That means first piston will move here, next piston will move here, next piston will move here, like that in infinite number of steps, for 1,000 number of steps, for a lakh number of steps, right? The piston will reach us from this solid line to dotted line. That means reversible process involves so many number of steps, right? So, but coming to the irreversible process, so the piston from solid line to dotted line, right? From solid line to dotted line, it may move in one step. Like that. To understand you better, I am explaining, right? So the reversible process happens with infinite number of steps. The reversible process, it is a sudden change, right? So suppose if I take this as V1 and V2, right? From V1 to V2, to the crystal, to need to move from V1 to V2, it may take 10 lakh steps, or it may take 10,000 steps. But in irreversible process, suddenly it moves from V1 to V2. In irreversible process, suddenly it moves from V1 to V2. That is the difference between the reversible process and irreversible process. I hope you understand now, right? In the reversible process, very small change is happening. N number of steps means, so from moving here to here, it taking us 10,000 steps, 1 lakh step means, so each step is very small. And negligible change, isn't it? So that's why we can take in reversible process P external equal to P gas. That's why we can take in reversible process P external equal to P gas, right? So for P external equal to P gas, we can take in reversible process. In a irreversible process, suddenly it is changing. Suddenly it is moving from V1 to V2. Sudden change. Sudden change means we can't take P external equal to P gas. So P external equal to, P external not equal to P gas. That's why, right? So if P external equal to not equal to P gas, and for expansion we may mention P gas, P external. Right? For expansion we can mention P gas is greater than P external. If P inside the gas is very much more means P inside the gas very much it bursts. P inside the gas is very much more means it bursts. That's why the expansion happens very suddenly. So P external equal to not P gas. So P gas is for expansion P gas pressure is much more than P external. So this is irreversible process, right? So I think you understand reversible and irreversible. Reversible process happens with so many n number of steps, infinite number of steps. Irreversible process happens with a sudden change. For a reversible process, P external equal to P gas. For irreversible process, P external not equal to P gas. And in reversible process, there is it is happening with infinite number of steps, but thereby at each step there is equilibrium will be established. Now for 1 lakh steps it is happening very small changes. From V1 to it is moving. That's a very small change. That is, there is a chance of establishment of equilibrium. So in reversible process, equilibrium will be established. In irreversible process, all of a sudden it is happening, all of a sudden it is moving, no chance of equilibrium. There is no chance of equilibrium. And we have the formulas for reversible process and irreversible process that I will show you how they will come. Briefly I will show you how they will come. And one more thing, for reversible process, observe carefully, we are mentioning P gas equal to P external. For a reversible process, we are mentioning P gas equal to P external. So we can write the ideal gas equation for P external also. Right? P external may be gas or maybe a force. We can move P external maybe with our hand also we can do the P external. Or gas may do the P external. Gas may be the P external pressure. So for reversible process, we can take P external equal to P gas. Right? That means P external also we can apply ideal gas equation. That is P equal to nRT. What I am going to say is, in a reversible process, P external equal to P gas. Inside P gas follows ideal gas equation. Inside P gas follows ideal gas equation. Since in a reversible process, P external equal to P gas, that's why you can apply the ideal gas equation for P external also. For P external also, we can write the ideal gas equation. For irreversible process, P external not equal to P gas, so P external we can't write ideal gas equation. P equal to nRT we can't write for P external for irreversible process, right? So as we know, work is equal to, right? Work equal to minus P external into dV. Minus P external into dV. Why minus coming here? So in definition itself we are mentioning to achieve the motion against opposite force it is happening. That's why we are mentioning the negative charge. W equal to minus P external into dV. I am coming to the reversible process. First I will derive reversible process. So W reversible I will write. I told you here P external equal to P gas. That's why in place of P external, right, I will give P gas into dV, right? And one more important thing here is minus. Okay, minus. One more important here is we are integrating here. We are using the symbol. We are using here integration. Why we are using integration? Why we are using integration for reversible process? So if you observe a irreversible process, there is no integration. But in reversible process, we are integration means summation of the terms. So integration means summation, right? So reversible process happening in infinite number of steps. Reversible process happening in infinite number of steps. So we need to add those steps. We need to add those infinite number of steps. That's why we are doing integration over here. I repeat, reversible process happening in infinite number of steps. So for that we need to do the summation. So in the form of integration we are doing the summation. That's why for reversible process we are using integration. So we can write W reversible process equal to minus P gas into delta V. So we can write this as, right, minus P gas into dV. Okay, minus P gas into dV, V1, V2. So this is for reversible process. While coming to the irreversible process, first write P external into dV. This is the work formula. P external into dV. Now, while writing the irreversible process, right? So P external is not equal to P gas. So we need to keep this P external as it is. While writing for irreversible process, P external is not equal to P gas. So we need to keep the P external as it is into dV, right? So W equal to minus P external into, here change is coming, not infinite number of steps. There is a sudden change from V1 to V2. That's why we are not doing integration here. We will directly write dV means change, final value minus initial value. So we will write V2 minus V1. Right? I hope you understand now the difference between the two formulas. Right? Here we are doing integration since reversible process happens in infinite number of steps. But to sum that infinite number of steps, we are doing integration, and P external equal to P gas. That's why in place of P external, P external, we can write the P gas. Here, W equal to minus P external into dV. Here P external not equal to P gas. That's why we will write directly. We will put only P external, right? So dV in a sudden change, one step it is change happening. So dV we can write V2 minus V1. Okay. I think now you understood the difference between the reversible and irreversible process. The minus n for work we are giving, right? Why we are giving? It is the motion against opposing force. Work is the motion against opposing force. It is the motion against the opposing force. That's why we are first in work we are giving negative sign in equation, right? And one more thing. For expansion, the work done is negative. For expansion, the work done is negative. For compression, work done is positive. How can you say? Take this equation. Take the equation. What I am saying? For expansion, work done is negative. I am saying. For expansion, which one is bigger? V2 is bigger. So this is the expansion, right? If you take expansion, so this is expansion only. This is the V1 value. This is the V2 value. So V2 value is bigger. So here also we are substituting bigger value minus smaller value. For expansion, V2 is bigger, V1 is smaller. Here we are substituting bigger value minus smaller value. So here positive will come. Negative into positive, negative. That's why for expansion we are getting negative. I repeat, for expansion means gas from V1 to V2. So V2 is more value, V1 is less value. Here V2 is more value, V1 is less value. So positive will come, right? Total positive will come. This positive into negative, this positive into negative. So for expansion, the work done is negative. For expansion, the work done is negative. For compression, now we will check. For compression, what will happen? For compression, V1, V2, right? So compression will happen like this. If you take the compression, okay. So assume that this is the V1. So this will become V2. Compression means pulling down the piston, right? So this will V1, this is V2. If you write in the formula, W equal to minus P external into dV, right? So minus P external into V2 minus V1. If you write the formula, minus P external into dV, minus P external into V2 minus V1, right? For compression, right? Which one is bigger? V1 is bigger. So here V1, V2, V1 is above, right? V1 is bigger, V2 is lesser. So here what will come? Small value minus big value. Small value minus big value, negative will come. Small value minus V2 is small, V2 is right smaller, V1 is bigger. Small value minus big value, negative value will come. So negative into negative, positive. Negative into negative, positive. So for compression, we will work done is positive, right? I will brief this and I will stop. So work is motion against opposing force. We have two works, PV work and non-PV work. Thermodynamics we used to deal with PV work, right? PV work is of two types, compression and expansion, right? If P gas is more than the P external, expansion happens. If P external is more than P gas, compression happens. Next, sign, if system absorbs heat, it gains energy, so positive sign will come. If system loses heat, it loses energy, so negative sign will come. So Q absorb, when a system absorbs is positive sign, when a system loses heat, negative sign. Work done means the system uses its work to do the work. So work done by the system is negative, work done on the system is positive. And reversible process happens in an infinite number of steps, and irreversible process happens all of a sudden. So we integrate the infinite number of steps to get the work done. Here right? We will calculate the initial value and final value. We will multiply the just initial value and final value with the P external to get the irreversible work. And final conclusion is, for expansion, the work done is